This video tutorial is on using a custom controller plugin in Nav2 for Turtlebot 3 on ROS2 Humble. The first step is to run the bring up on the robot. So in our bottom right terminal here, as is with every terminal meant to use ROS, we're going to source it. Now you only have to do the build once, but in case you haven't done that, here's the build running. And then source the build. Now we run the bring up command. And once run displays on the bottom, we are ready to go. The next step is to launch Nav2. Here in the top right terminal, we are launching Nav2 and setting the use RViz parameter equal to false, as we will be using the Nav2 interface package. And this is what you should do every time you're using a low-level PC like the Raspberry Pi 4. Now we're going to go to our parameter file that is custom for our controller. So we're going to navigate to this parameter file inside of our custom controller package, copy the path, and paste it into the command. We're going to do a similar thing for the custom SLAM generated map. You could see how to map using SLAM in a different tutorial. You copy the map file path and paste it into the command. Once you hit enter, Nav2 will start to boot and it is ready to go. After launching Nav2, we will move on to running our Nav2 interface package. Once running that command, you will get a display of instructions on how to use the program, and it will ask you for the path to your map file. This should be the same map file that you used when launching Nav2. After doing this, it will load for a second. And then you will get a display of your map overlaid with a coordinate grid. Now moving your cursor around, you can get exact coordinates for any space on the map, which we will use for setting initial and goal poses. Now setting an initial pose is not required, but it is recommended to make sure that you have placed the robot exactly where you want it on the map. So you could see the 0, 0, 0 corresponds exactly to where the robot is on the map, which means we have done our initial pose correctly. Now we will get ready to set a goal pose, and these coordinates we obtained from the map grid. And before running a test, we're going to run the pose plotter node to make sure we get data. Now clicking enter, you can see the robot move in real time to navigate to the set goal pose. Now the robot has finished navigating. Once your trial is done, you hit Control C on the performance plotter node, and you'll get data for the run. You could save these plots directly to your computer. Now in this case, I'll be terminating all nodes and starting a new test. However, you are still able to give it a new goal pose and have the robot navigate around the map. But in this case, I want to do a brand new test, so I'm going to terminate all nodes in all terminals, and I'm going to set my environment for a new test. Here I want to test obstacle avoidance, so I'm going to set obstacles in the map and put my robot back to the origin. Make sure when you're doing a new test to hit the reset button on the OpenCR board. This will reset your frames and make sure you get a clean test after terminating the previous. And we will be running the same exact commands as the previous test. So we run the bring up. We run Nav2. We run the interface and do the same steps as before, inputting the path to the map file. The same map will display. Notice that the obstacles are not there since these were not mapped. We overrun the pose plotter to get data from the run. And just like before, give it an initial pose, which again is not required, but it is good practice. And now we will give it the same goal pose and see how the robot behaves navigating around the obstacles. Now we can see the robot takes a new path around the obstacles to get to the same goal pose. Once the robot has navigated, you can terminate the performance plotter node and get data from that run. You can cross-compare the data after saving it to your PC and see how your robot responds with obstacles in the way or with obstacles not there.